Hello everyone and welcome to today's tutorial. Today we'll use R language to create, evaluate and score a fraud detection model. This tutorial presents an end-to-end example of a Synapse Data Science workflow in Microsoft Fabric. In this scenario, we'll build a fraud detection model in R with machine learning algorithm trained on historical data. So let's proceed with the lab. First of all, go to the website app.fabric.microsoft.com. Then here you need to sign in with your Microsoft ID. Then here make sure that in the left corner the Fabric is shows. By default sometimes come with the Power BI, so make sure that it should be in Fabric. Then go to workspaces on the left hand side and click on my workspace, and here we need to click on new item. So we need to create a new item, so click on new item, and here we need to search for notebook. So first of all, here in the filter write notebook, then click on the notebook, and soon it will create. So it is the home page of a notebook. So here make sure that the language chosen is R. So we are dealing with the R language, so choose your R, Spark R, that is. Then next we will install some custom libraries. So I will write the code here and copy it from here. After that, click on the play button to run this cell, and soon this code cell will run. So we need to wait until the installation completes. Now we can see our session is ready, and if we expand the logs, you can see the libraries are being installed. So we need to wait for it to complete. So we can see our command has been executed. So next we'll load some data to it. So first of all, we need to create a new cell. So click on the plus code button, and here we need to write some code. So you can copy the code from here. Then we need to hit on the play button to run this cell. So you can see command has been executed. So next we need to create another cell, and here we need to write some code. So you can write the code from here. We need to wait until the command got executed. So you can see our command is executed, and it is downloading demo data from files into lakehouse. Next we will read the raw data from the lakehouse. So create another cell first, and here we need to write the code. Then hit on the play button to run this cell, and it will start reading the data. So basically we are reading the raw data from the lakehouse. So you can see our command is executed. Next we need to perform some exploratory data analysis. So basically we will display the command, we will display the high level statistics of the dataset. So first of all, click on the add code cell. Then here we need to add some code. Then here you need to click the play button to execute this command. So you can see our command is running right now. So you can also see some jobs are running. So you can see the table here. Next we need to print dataset basic information. So you need to write the code. So you can copy the code from here. So it read 2,84,807 data. So next we need to write the code. If the sample is true, then only sample rows will go to training. So you need to write the code here. Then hit on the run cell button, and we can see our command is executed. Next we need to print the distribution of the classes in the dataset. So again add a cell. Then here we need to write the code. Then click on the play button to run this cell, and you can see the fraud percentage is 0.17 of the data set, and 99.83% are not fraud. Next, we'll view the distribution of the fraudulent versus non-fraudulent transactions. So again, add a cell and write this code over here. Then hit on the play button to execute this code, and we can see fraud and non-fraud dataset are showing in the visualization form. After that, we'll show the 5-number summary, that is minimum score, first quartile, median, third quartile, and maximum score for the transaction amount with box plot. So again, add a cell, then here need to write the code. Then click on the play button, run this cell, and we can see the following in visualization form. Next, we will train and evaluate the model. So first of all, we need to prepare the test cases. So first of all, we need to split the dataset into training and test datasets. So again, click on add a new cell, then write the code over here. Then hit the play button to execute this code. And now we can see our dataset has split it into two parts. One is training and other is test. So we'll apply synthetic minority oversampling technique, that is SMOTE, in the dataset for the training dataset specifically. So first of all, add a new cell, and here we need to write the code. Then hit the play button to run this code. Sorry, I need. You can see it is running till now. So we can see command is executed and the results are shown over here. Next, we need to train the model with light GVM. So first of all, write the code over here. And here, hit the play button, run this cell. So command is executed right now. We can see the logs over here and the outcome over here. So start training with the balance data. There's write GVM. Next, we need to determine the feature importance. So again, add a cell and write the code over here. You can copy the code from here and hit on the play button to run this cell, and we can see the visual form of the following data, and on the y-axis you can see the recorded feature and frequency, and x-axis we have frequency. So you also need to show the data for this. You need to show the another importance. So again, write a code over here. So it is basically calculation by the smart process. So next we will evaluate the model. So here so we will evaluate the two trained models, that is model trained on raw imbalanced data and smart model trained on balanced data. So again, create a new cell over here, and here we need to write some code. Then hit on the play button. Now you can see a command is executed. Next, we will evaluate model performance with confusion matrix. Confusion matrix display the number of true positive, that is TP, true negative, that is TN, false positive, that is FP, and false negative, that is FN, that a model produces when the record when this data model produces when scored with test data. For binary classification, the model written as 22 confusion matrix. For multi-class classification, the model returns an n into n confusion matrix where n is the number of classes. So we'll create some confusion matrix over here. Click on the add code cell. Then we need to add some code over here. Then you can copy the code from here and then hit on the play button to run this cell. So you can see our command is executed. Next, we'll plot the confusion matrix for the model trained on the imbalanced data set. So again, add a cell, then write some code over here. You can copy the code from here. And next, we'll click on the play button to run this cell. And we can see the visualization for the confusion matrix for the imbalanced data set. So likewise, we'll create a visualization for the balanced data set. So again, add a cell, then write the code over here. And click on the play button to run this cell. So we can see confusion matrix for balanced data set. Now we'll evaluate the model performance with the AUC-ROC and AUP-RC measures. AUC-ROC is the area under the curve receiver operating characteristic, and AUPRC is the area under the precise recall curve. So first of all, add a new column over here, and we need to write some data over here, code over here. So you can copy the code from here. So we are basically installing some packages and load the library over here. So hit on the play button to run this cell. Next, we'll calculate the AUC, ROC and AUP RC matrices for imbalance and balanced dataset. So first of all, we'll go with the imbalance dataset. So click on the add column, and here you need to write the code over here. Sorry. And hit on the play button. Now again add a cell over here to print the data under the curve. So you need to write the code over here and hit on the play button to run this cell. And we can see the area under the curve data over here. And for visualization, just simply write code over here. Again add a column over here. And this command will visualize the AUC ROC curve. Now similarly we'll go with the AUP RC curve. So again add a column over here and write the code. Hit on the play button to run this cell. And for visualization, again write the same code. Then hit on the play button to run this cell, and you can see the AUP RC curve. Next, we'll go with the balanced dataset via smart dataset. So again, add a new column over here and write some code over here. Then hit on the play button to run this cell. Then again add a cell, and we'll first do the AUC ROC curve. Hit on the play button, and again we will visualize this curve over here. Hit on the play button to visualize. So we can see the AUC ROC curve for the balanced dataset. Next, we'll do similarly for the AUPRC. So again, we need to write the code over here. Hit on the play button, run this cell, and for visualization, we need to add another cell over here, and just write the code over here. And hit on the play button to run this cell, and we can see our AUPRC curve is ready. So that's all for the lab. Thank you.